Ladies and gentlemen, boys and girls, children of all ages, it's Mr. Cockbrenner. Alright, guess what? It's time. Time to do what? It's time to do exponential function word problems. Are you ready? Sit back, relax, buckle up, because here we go. Boom. Today's objective, pretty obvious. I think I've already said it. Solve problems involving exponential growth and decay. We're going to have 5 equations, which seems overwhelming, but I think what we're going to do is maybe give you a Word doc or a Google Doc with these formulas to help you out as you solve these problems. All right, so here's the first equation. It's exponential growth. We could tell it's growth based off of what? This plus sign. Anytime we're going to be adding, obviously it's going to be growing. We already did talk about this day 1, so it shouldn't be too new as far as what we're looking at here. Again, we have that parenthesis, which was our growth factor. Factor, again, remember, means multiplication. And then the rate, that R that's represented there with the green, is going to be in the form of a decimal. Shout out to the decimal there. So other than that, let's stop looking at the formula and let's start using it. So annual sales for a clothing store are $270,000 and are increasing at a rate of 7% per year for 3 years. So now we need to figure out what that final amount is in sales. So here's the deal. Forget that comma right there. It doesn't matter. If we look here, we have all these variables explained to us. All right. So all we have to do is plug this in. So what I did when I made the notes was kind of like leave the skeleton model that's going to stay there. And then we're just going to plug in our values. So ready? A is outside of parentheses. So it's this box right here is A. So A says what? Do our research. It says A represents the original amount. So what's our original amount? So again, I like to highlight the information that's thrown at me. And obviously we're in math class, so guess what? Numbers mean something here. So now we have to decide. We have 3 numbers, we have 3 boxes. So those 3 numbers have to go in those 3 boxes, and obviously order matters. So if A is the original amount, we have 270,000 going in this box. R is the rate, and again, I'm going to highlight this word right here. We have a decimal, so if we have 7%, remember we have to move that decimal point 2 spots to the left. So if we have 7 here, here's a decimal point, 1, 2. We have 0.07. So that's going to be my growth factor, 1 plus 0.07 or 1.07. And then the last but not least, we can check this box off, check this box off. 3 years is going to be my exponent. So again, these are called exponential functions because we have a exponent that is a variable. So now how do you solve this? All right, you can do multiple things. I don't know. I'm going to do something that we tell you to do every time. What is it? Boom, Desmo. So this is a problem that I was working on before. Excuse my work. But when we look at that, this number here was 270,000. So I'm going to type 270,000. Boom, 270,000. I have my 1 plus 0.7, and then to the third power. And what do I get for my answer? 330,761 and 61 cents. So if it didn't round to that 100th spot, we would round it to the 100th spot due to the fact that it is money, and we round to that nearest penny. So again, in 3 years, our sales would be 330,761 and 61 cents. Ching, ching. We're doing well. Any questions? Again, what am I doing? Using my best friend Desmos, plugging in the 3 boxes, the 3 numbers that they gave me, bada bing, bada boom, let's go. Exponential decay. So if you notice, this looks very, very similar. The only difference, like we talked about last block, was that minus sign. When that number, that growth factor inside of parentheses, remember, is less than 1, it's going to be decay. All right, so this number should be getting smaller. And again, that word right there is going to be huge, decimal. Make sure that you're taking your percent and changing it to a decimal, doing that decimal slide. the decimal slide. All right, the population of a school is 800 and is decreasing at a rate of 2% per year. So what does that look like? So again, it's the same bare bones I got right there. Y equals box, parenthesis 1 minus, because it's decay. That box, parenthesis, exponent box. So we need to fill in the boxes. Hey, guess what? I have 800. I have a 2% decay. And I have 4 years. So 3 boxes, 3 bits of information. We need to just make sure that we're putting things where they go. All right. So the amount, all right, that represents the original amount was 800. So that's going to go in box number 1 there. What goes in R? Again, we can just look at my notes here. R represents the rate of decay as a decimal. So what is 2%? Remember, our decimal's behind 2, so we got to go 1, 2 spots to the left, and we're at minus 0.02. So that growth factor is going to be 0.98 if you did the subtraction. And then T is the time, so in 4 years. So we have 3 numbers again, and we're just going to put them in the 3 boxes that we're missing. Again, I can do the math if I really wanted to, but I'm going to be intelligently lazy and use my best friend. What's my best friend here? Desmos. And again, before with growth, it was a positive inside that growth factor. It's going to be a subtraction. And I need to change that 0.07 to 0.02. And then change that 3 to a 4. That was my old problem. So now, how many students are going to be there? In 4 years, the enrollment, that population is going to be 737.89. So since we're dealing with discrete information, that's a distinct point, we can't have 373.89 people. That's very odd if we did. So let's round 737.89 to what? Are we keeping it 737 or are we making it 738? Let's round up and make it 738. If you did have the option for A, B, C, D, E, if it was a multiple choice, and you saw 738 or 737, those are the 2 values that I would choose. I would round up just because it is going to be people. And we need a whole person. Half-life. Ooh, spooky, Mr. Gawkrunner. Looks like Halloween colors. You're right. It is. Boo. Half-life. So what's going on here? Again, y equals a parenthesis 1 half. That's the half-life. Now, if you notice, we do have a little bit of a difference up here with our exponent. No big deal. It's a quick division problem. T is the time, so the total time, and then we're going to get a half-life time. So we're going to have the half-life time on the bottom, so it's a quick hit. You can actually put it in Desmos. However, if you look at this, this is just saying that, remember how it's decay because this number inside of parentheses is 1/2. So it's going to be 0.5. So it's always going to be 1 minus 0.5. So that growth factor, because growth factor means multiplication, right, is always going to be 0.5 because we're cutting things in half. So cesium-137, so there's going to be a dummy variable, just to let you know, has a half-life of 30 years. Find the amount of cesium-137 left from a 100 milligram sample after 180 years. So, again, we have numbers that we need to pay attention to because it's math class. So I'm just going to highlight the information here. And you can see that here, my bubble that I have is going to look like this, my skeleton model. So I know that this is 1/2 all the time because it's the half-life. So now I have 3 boxes. Again, A is what? A is your initial amount. So I have 137, I have 30, I have 137 again, I have 100, and I have 180. So I have 5 numbers to choose from. So now I need to be a little bit more careful because the last ones were a little bit easier because they just had 3 numbers and 3 boxes. Now we have cesium-137. That's getting into science, all right? So there's different isotopes of cesium, and that depends on protons, neutrons, and electrons, and the mass and all that good stuff. I know some people love this lesson because we're blending someone's favorite subject, science, with math. So it's really showing you how that math-science connection is coming about. So hopefully that tickles some of your fancies. Yeah, I said that. I'm 38 now. My birthday was last Monday. So, anywho, let's figure out what's my initial amount. Is it cesium-137? This says half-life of 30 years, so that's kind of going to be my half-life time, I'm assuming. So this is probably going to be my H. It's an H. Find the amount of cesium-137. So that's like just telling you what I'm dealing with. So I don't think these are that important, to be honest with you. Left from 100 milligrams sample. So hey, there's my initial amount. So my initial amount right here is going to be 100. Now it says after 180 years. So 180 years is the total amount of time. So this is going to be my T, giving me my A, my T, and my H. What goes up top in the numerator? My T. So my T is 180. So 180 is going to go in there. And then my half-life time is going to be 30. I can do one of two things. I can just type that in to Desmos, maybe 100. This is obviously going to be what? 1 divided by 2, because it's my half-life. And then I could even do 180 divided by 30. Now I'm going to get what left over? I'm going to have, after 6 half-lives, if you really want to look at that and simplify that exponent of 6, there's going to be 1.5625 what? Milligrams mg of cesium, I think it's S or CS 137 left over. After 180 years, we're just going to keep cutting it in half 6 times, and we're going to have 1.5625. And be specific, it doesn't give you, hey, round to the nearest tenth, hundredth, so make sure that you copy that whole number down from Desmos. All right? So again, if you notice, we're actually not doing too much math as far as computing because we're letting our best friend Desmos do it for us. We just have to make sure that we're organized. And trust me, I just put my kids to bed, and my son's room is not organized at all. He had a soccer match yesterday, which he won 2-0, had an assist, played really well. However, he left his clothes on the floor. And I go, where do those go? You need to put that away. Just like we're putting numbers away into the spots on the formula, he needs to put his clothes in spots like the hamper. But enough of that. Compound interest. So this is about money. So hey, listen up. If you want to learn about money, here you go. We want your money to compound interest. All right. We want these compounding as much as we possibly can because that means your money is going to grow faster. So if you notice, we have new letters come in here. We have an N in orange. All right. But we're going to go over this real quick. Just to show you how closely related they are to the growth. But as you can see, this is growth because it's a plus sign. Down here, I do give you some bits and parts to pay attention to. Annually means once a year, so your N is 1. Quarterly, just like there's 4 quarters in the dollar, that means your N is 4. Monthly obviously means 12. If you had something that said daily, that means 365. So that's what you really want, is the more you can compound that money, the more money you're going to make. So, on your mark, get set, let's go. $35,000 invested at a rate of 6% compounded monthly for 10 years. So again, let's highlight our information. Monthly, 10 years. What's my initial amount? Because that's what my A value is here. I'm sorry, my P value right here outside of parentheses. My A value is going to be my total. That's going to be 35,000 smackaroonies. And then up top, what goes up top? My rate. Remember what rate? Rate has to be a decimal. So it's 6% or 0.06. What is N? N is the number of times it's going to be compounded. How many times is it going to be compounded? Monthly. So how many months are there in a year? 12. So that goes down in the numerator or denominator here. And also up here in the exponent, the exponential function, obviously. And then now, last but not least, we have 10 years, so we're going to put a 10 next to it. So, again, you can do, I don't suggest it, but hey, I'm going to use Desmos. That's probably the most simplest way to go about this. And now inside, we're going to be talking about growth. So notice how I don't erase everything in Desmos. I'm going to use my prior information that I had. and just backspace it out there. So 1 plus 0.06 divided by 12. All right. So again, be careful because we're not done up there in our exponent. So in parentheses, I'm just going to say 12 times 10. So again, this is going to do all the work for me. I just need to make sure that I'm putting it in correctly and making sure it matches what I have here in that skeleton model, putting the numbers where they go, compartmentalizing it properly, and then making sure that that mirrors over there in Desmos. So again, now my $35,000 after 10 years is $63,678, and we need to round to the nearest penny, so that's 89. All right, so it's not bad. After 10 years, your money almost doubled, which is pretty impressive to do. So if you can get a rate of 6%, good for you, because that's not happening anymore right now. Back in the day, it used to. However, now, not so lucky. All right, so using this same problem, I want to show you something in Desmos. I'm going to bring this over here. We want to know when that $35,000 is going to turn into $100,000. All right, so how many years will it turn into $100,000? So if I look at this equation, I want A to equal what? I want A to equal 100,000. So what I'm going to do is bring this over here real quick. I'm going to make this x, and that's going to create something, an exponential function. So it's going to be a curve. All right, so let's see if I zoom out. You see that exponential curve right there? Let me just zoom in real quick, because when I zoom out really far, it's going to look like a line. But obviously this part right here, when we're zoomed in, is not going to be a line. It's obviously a curve. If you notice, my initial value of $35,000 is my what? It's the A value. So if you recall from day one, that was my y-intercept, right? So if you notice, my y-axis right now is going by 50s. So I need to keep zooming out until I get to what? 35,000. So I'm at 5,000, 10,000, 20,000, 40,000. Boom. What is that? Silver ball, silver ball. There it is, right? 0, 35,000. Sorry, it's getting late. So I know that that is my A value, and I can prove it because the silver ball from Desmos tells me so. So what did I want? I wanted y to equal how much? 100,000. So when will my final amount be 100,000? So what I'm going to do is right now I'm only at 20,000. Here's 40,000. I'm just going to keep zooming out until I see what? Right there. What do you notice? There's a silver ball right here. All right. Right now it's on the blue line. Again, this is a 0 slope because it's a horizontal line. There's no change in rate of change. It's 0. I'm going to click on this, and I'm going to do systems of equations of an exponential and a linear equation. If I click on this, what does this point tell me? It tells me 17.541 with 100,000. So this is, I think, a skill that we all need to work on, is understanding what the x value means and what the y value means. Well, if you look down here, y means what? 100,000. That's your money. So what is the x value? The x value is the amount of time, because remember, I just took this 10 out before, and I made it an x because I don't know that amount yet. But when I click on this, it tells me in 17 and a half years, just over, because it's 4.541, so just over what? 17.54 years, right? Is when my money is going to reach 100,000. So 17.54 0.4 or 5.4, so 17 and a half, let's call it, years it will take to reach $100,000. So what is that? 17 years and 6 months, because remember that half a year is 6 months. All right. Last but not least, a person invested $3,700 in an account growing at a rate allowing the money to double every 6 years. How much money would be in the account after 14 years to the nearest dollar? So ready? Here's your initial amount. What do you think T stands for? That's the amount of time. How long is it going to double? Every what? 6 years? Oh, I'm already putting all my answers in there. So you have 3,700. Why is this growth factor 2? Because what is my money doing? My money is doubling. So I'm going to take it and multiply it by 2. So it makes sense that that multiplier is 2. And again, this number in that growth factor is greater than 1. So we know that our number is going to obviously get larger. And now we have 14 divided by 6. So let's plug that information into our best friend, Desmos. And we get all that garbage inside. That growth factor is 2. And now let's put, we said we're going to be 14 years divided by 6 years. We are going to have a nice amount of money, $18,646, and it says round to the nearest dollar, so that's going to round up to $647. $18,647. All right. Any questions? Again, we have growth, exponential growth, and we have exponential decay. And that's what I'm going to teach you right here on this page. So this is what your Google Docs is going to look like. I'm just going to copy and paste what I have down. But if you look, I split it up. This is my growth because you have plus times 2. And then this is my decay over here. So I can write growth here. And decay here. Decay because we know that we're minusing that rate. And then this is already 0.5, aka the 1/2. Any questions, please, you know what to do. Pause, rewind, repeat. Email is the easiest way to contact us. If you love the video, give me that thumbs up, like, and subscribe. Other than that, Felly, you're welcome. You told me to split the screen. I listened. Take care, guys. Have a great day. Cockbrenner out.